Have you ever been programming in C++ for Unreal Engine, hit a roadblock, and realized you would need a third-party library to get around that? Have you ever been in Blueprints, realized you wanted to access an SDK, but you don't want to buy some massive package off the asset store that contains the two functions you need? Or have you ever been sitting around just contemplating life and wondered, how can I access third-party libraries within Unreal Engine? If you've done any of these things or more, you are quite likely going to benefit from this tutorial. We're going to be showing you how you can connect to third-party libraries that are already inside of Unreal Engine in just a few minutes. It's super simple and quick, so let's get started. So if you look inside of the Unreal Engine installation you can go to your engines directory, then source and third party. Once you're in here, you will see that there is a vast assortment of all of these libraries just sitting inside of Unreal, and they're not exactly the simplest to get to. But there's a lot of good reasons to try and get to these libraries because they can help make your project a lot simpler in the way that you code and just simply in the size of the project. So again, like I mentioned, the first reason that you should definitely try and use third-party libraries that are inside of Unreal Engine already if you can is because it will just reduce bloat and file size. A lot of times when you run into a scenario when you need a third-party library, you may be tempted to just go ahead and make a third-party folder in your own module that you're working in. And this can work until it doesn't. First of all, if you just make a third-party folder and include a library that Unreal Engine already does have in its third-party folder, your project will come crashing down in a cascade of errors quite likely because the project is going to have trouble knowing which library is which. So if you can, it's best to avoid that and try and use what Unreal Engine already has. Now, to be very specific, if you're using something like the Steamworks SDK, the version specifically that's in Unreal Engine might not have everything you need, but for the most part, these libraries that it has are generally pretty constant, and if you can get away with using them, I highly recommend it. Now, the second reason that you will want to use the Unreal Engine third-party libraries instead of importing a third-party library yourself into your module is if you're making a plugin, you don't need to check that uses third-party libraries box. Saves you a lot of time, makes things a lot simpler for licensing and everything because it's already in Unreal Engine. And the last reason is if you need one or two functions out of one of these third-party libraries or something similar, and you don't want to buy some big pack of like 50 functions for Blueprints or something off the asset store, you can just make it yourself in a few minutes because you can access it really simply. Now, what I'm going to be doing for this video is I'm going to be going over how you can actually include any of these third-party libraries. This works for any of them. I'm using one of these as an example. One thing to note beforehand is that some of these libraries, depending on your installation, may actually not have anything inside of the folder. For example, this is just the blank file that labels this as a third-party source for Unreal Engine, and then there's no actual source code in here. This is because this version of Unreal Engine has been installed off of the Epic Games launcher. If you go to the Epic Games source, every single one of these third-party sources will have the full source code inside, so you can get it all there whenever you need it. But the library I'm going to be using for this example is Keep It Simple Stupid Fast Fourier Transform. Now, Dexia says when I look at it, that this says KISS feet. And that's just faster than any other way you can say it, because you can say KISS Fast Fourier Transform, Keep It Simple Stupid FFT, KISS FFT. KISS feet is just simple and easy, and it looks like the developer may or may not have thought of that when they made it, but at a quick glance, it looks like that. You can actually go see the full KISS FFT, KISS feet library here, and go check it out yourself. It is just out on GitHub, or you can find it in the Unreal Engine source. Huge shout shout out to the creator of this library because it really does do what it says. It does do a quick Fourier transform and it keeps it super simple. Again, you can read more about it here, but we are going to go access it from our Unreal Engine. So I just have a blank Unreal Engine project loaded up here. It's configured for C++. So what we'll need to do to access this is we will need to go create a C++ class to access this inside of our module. So I'm going to use an actor because this way we can throw it out into the world for debugging purposes. So we can go and make it, we can just call this FFT actor and create the class. So the first thing we will want to do to include our third-party library is to make sure that it is actually included in our module. So what we can do first here is we can open up our build.cs. And there's two ways you can do this. You can either add a private static dependency or a private dynamic dependency. That is the best way to go about doing this. If you start typing add, you should see them come up right here at the top. These are your two options for these. And so I'm just going to do a static dependency since that's all KISS feed is. We just simply put in the target and the name. And it's important that when you're typing in this name here, that it is simply the exact same as what you see on these folders. So I'm going to type it in right as I see there, and it should include the library just fine. So KISS FFT, and that should be good to go. So we can save it. So let's go ahead and build it. And in order to build it, we'll need to shut down Unreal Engine. And don't build it too fast. And okay, so it built just fine. That means we are good to go. It was able to actually connect to the KISS feed library just fine. So now that we have successfully connected to the library, next step is to actually include the header files. All right, now for those of you that already paid attention, you know that we were in Unreal Engine 5.6, so that will actually make a difference here in how we include our third party. There are different rules for best practices when importing the actual third-party library header files into your own files in the module. It varies version by version of Unreal, so I will be going over some of these rules here for how to actually import them. So in order to include the library headers, we need to go up here to our header includes. Always make sure that the generated.h is at the bottom. So now this is where the rules for these includes get a little weird. There is different compiler pre-setup files that you need to include to get the proper macros to wrap around your external library includes. And these files and their contents differ based on your Unreal Engine version. Now we are in version 5.6 right now, so I will just show you how the 5.6 version works right now, and then I will go over the changes you would need to make based on version and operating system, because operating system will also influence this a little bit. So step one is you will need to write out pragma default visibility start, and then you will need to do third party include start. And then this is where we will actually include our file is in there. And then we will do third party includes end and default visibility end. Okay, so these are what need to wrap your calls to your external library. These provide things like this just disables warnings and basically just configures stuff to kind of connect between an Unreal Engine C++ project and these external libraries. Most of it's really just done for you. Usually just adding these around your third-party includes should work just fine. So coming back to here for the different rules on your Unreal Engine version and your operating system that you're targeting. You need to keep in mind, even if you're building this on one operating system, if you're intending it for any of these ranges of operating systems, you will need to make sure that these are accounted for. You can just do your simple if-else preprocessors for this. But let's get started in the list of really weird things that you'll need to know to make sure you include it for your right engine version and your right target operating systems. So the first thing you'll want to do is, if you are on Unreal Engine version 5.2 or less, as long as it is a 5.0 version. I'm not 100% certain about Unreal Engine 4 versions, but at least on Unreal Engine 5, if you're on version 5.2 or below on Windows, Apple, or any Unix-derived system, you will need to do if and then defined, and then whatever the macro is that defines your operating system. I am on Windows right now, so this would be Win64. And in certain cases, this can also be Win32. So we're going to leave that option there too. And inside this macro, what we will include is a special file that helps define the third-party includes for this operating system in that version of Unreal Engine. And so for this, we will do include Windows, window, maybe not, Windows, platform, compiler presetup.h. Quite a mouthful, but you'll want to make sure you capitalize that S too. But what this will do on Unreal Engine 5.2 or less for Windows, Apple, or Unix drive systems is it will actually contain this third-party include start macro and the end macro as well. I'm on Unreal Engine 5.6 right now. These are predefined on the generic platform compiler presetup, which is by default comes along with Core Minimal, I believe. So you won't need to do this above 5.2, only for Windows or Apple. However, Unix will still need this through 5.6. Again, it's pretty weird. So Windows and Apple, you need this below 5.2. And on Unix, you will always need this definition. And it follows the same pattern here for your operating system. So if you're on Apple, it is Apple, and then Apple platform compiler presetup. And then Unix, it's Unix platform compiler presetup. So it's the same here. Obviously, you wouldn't do this. You would do this for your own operating system macros. And so that's the rules for getting your third-party includes macros in there. Now, here's another little complicated wrench in the whole thing. If you are building for an Apple operating system, you will still need your Apple platform compiler presetup, but this time you will need it for your Pragma default visibility start and end macros to be defined properly. So it's kind of a bit of a mess, but I'll also post these rules in the video repository as well, so you can keep track of them. But as long as you keep those in mind, you should be fine. You shouldn't encounter any build errors, warnings, or the like, and your process for this should be pretty smooth. So now that we have those, what we will need to do is include our actual header file, specifically from the KISS FFT library here. What this header file is, we're just going to be doing a normal fast Fourier transform for example. So we'll be doing KISS FFT.h. That's all you need. And that should be good to go right there. Now it is underlined. It's saying it can't open the source file. At least in Visual Studio, I've run across this problem, or it will say it can't open the source file, but it actually can, because if I save and build this right now, we can see it builds just fine. This is just kind of a weird problem with it not being able to connect to some of these external libraries and their header files. And what's even weirder is it's not consistent across all of these third-party libraries that Unreal Engine has. I've connected to some of them and it does not have trouble connecting to them at all. And then some of them, it just doesn't identify the header file. But the way to fix this is if you go and build into Unreal Engine and launch it, you can actually go ahead, refresh the Visual Studio project there, and then come back to Visual Studio, and there's a few steps that you can do to make sure it knows that this is a valid connection. So once we're here, we just go up to Tools, Refresh Visual Studio Project. You can also go to your Unreal Engine project file inside of your directory, right-click, and there may be a refresh button there too. I always go to the one in Engine just because it is always reliable. Sometimes if things are configured a little strangely, the one inside your file system may not work quite right. Okay, so the files are all refreshed. Let's close the Unreal Editor again. We hit reload when we get back to Visual Studio. This resets everything. Let Visual Studio think for a little bit. And now this still isn't resolved. So once you have refreshed the files, you can go to your project's properties, and then you'll go to VC++ directories. go to library directories, and put in library path without a curly brace. And then hit enter, apply, okay, let it think for a little bit again. And then once Visual Studio is done contemplating, you will see that everything is all error-free now, and that our include statement for our KISS FFT header file is actually working just fine. For this example function, we will just be returning a string, and we will just call this do as Fourier transform, and I'll leave it at that. So this will just return a string of data about the FFT. So we can save that as is. Once you have this function, we can go ahead and create a definition for it. So we can see if we go to KISS FFT, we actually have all of the objects and properties associated with that header file loaded in with IntelliSense right here. Even if you couldn't get your redlining fake error to resolve from Visual Studio, it will still build just fine. The only problem is IntelliSense won't be able to help you with things like this, so you'll just have to really know what you're doing. Anyways, so now that we can access this library, we can actually go ahead and perform a simple Fourier transform. So to do this, there's a couple things that you will need to do. You will need to define the number of intervals that it calculates at. So this is basically, think the number of samples in your time and your frequency domain that you will be looking at. So we can define, and I just call this NFFT. We'll be doing something super small because we're just going to be debugging this and testing it out to see what the output looks like when it's printed to screen in Unreal Engine. We can't do very much with this in Unreal Engine unless we spend a long time programming something very complicated for a visual analysis of this. Another thing you might want to define is the numeric type that the KISS FFT library would actually use. In this case, you would go ahead and define it. However, it will throw a macro redefinition warning in these projects, so it's kind of up to you on that. So now that we're here, what we'll also want to do is, I at least just set up a value that says is inverse FFT, and then this is going to be 0. And then here, what we will do is we will allocate memory for a KISS FFT config struct. So here we will do KISS FFT CFG config, basically config. Then we will use the alloc function here. And that's one thing to keep in mind with this library is it does mean that you need to manage your own memory. You are allocating something, you will need to deallocate things. And so for this function, what we will do is we will input our sample count, our inverse flag, if you will, and then the pointer to the memory and a pointer to the length of the memory. You don't need to worry about those. You can leave them null and it will still allocate what it needs to. These, I believe, are mostly for if you have a specific block of memory in mind that you want this to be allocated to. Otherwise, it will just dynamically allocate it more dynamically than if you had specified this. So now that we have this, we need to actually set up the data that we want to transform using the Fourier transform. So in this case, you can create two arrays, an in and an out array, both of lengths NFFT. So these arrays are of type KISS FFT and complex. So we can call these in and out. And with both of these defined, what we will do is our in array will be populated with our initial data, and then the out array will be referenced to and be populated with the output data of the transform. So for this, we can just do a simple little loop. And in here, we can say in, and then the ith value of the in array. And then we will set the real value. Just for an example function, we can do fmath square root of I plus 1. Now, one thing to keep in mind is we will need to cast this to the type that the complex struct for KISS FFT is expecting. Now, if we head here, we can see it's expecting two of these KISS FFT scalars, which are defined as floats. You can redefine them to be another type, but again, you'll get that compiler warning, so up to you. But now I know that these need to be floats, so we can cast them like so. And then since these are complex valued numbers, we also need to set our imaginary component. However, we're not going to need to worry about this for this analysis, so we can just leave that at 0. Now that we have done this, we can actually compute our fast Fourier transform. So we will just do KISS FFT, the official KISS feat function, and we pass in the config for this operation. Then we will pass in the arrays of our in and out, and the outs is a non-const reference, so this will be modified with the actual transform values. Then after this, what we need to do is we need to actually free our config before we forget. We won't be needing it anymore here, so we can do, they have a special little definition here. It just maps to a free, but it just looks nice and gets the message across very clearly that you are not only freeing an object, but you are freeing an object associated with this library here. With memory management, it is best to try and be as clear and easy to read as possible because it is naturally a very difficult to understand science. Lastly, now that our output data will be populated, we can make a string and put this data into it. Now, in this case, we can just make a string here and out string, and then we can just loop over the output of our results. And so NFFT, unless you define it as NFFTL, and then go ahead. And then we can just concatenate this out string, and then I went ahead and just created an F string format. I will just paste in here because it would be a pain to type out. I'm not going to for this tutorial, but it's right there. Basically, we just do the F string version of printf, and we show the real component, the imaginary component for each index in the out array. And then this string that we have concatenated to, we can just bring out of the function there. And that is our do fast Fourier transform function using a Unreal Engine third-party library. Now, lastly, it's probably a good idea to go ahead and test this. So what we can do is we can go up into our begin play function, and we can print this to the screen when this actor receives the begin play call, if it's inside the Unreal Engine world at the time. That should print it on the screen when we're all done. So let's go ahead, build this, run the engine, and check. So once you're back in the engine, you can go ahead, go down to your C++ classes, drag out the actor, and then when you hit the play button, you can see this. You will know it is for sure correct when it looks, something like a crypto wallet. That should be your input data of your square root of i+1 function, Fourier transform. So if you followed along, congratulations. You just connected to a third-party library in Unreal Engine in relatively little time. It's pretty simple, and it unlocks a powerful suite of libraries that Unreal Engine provides by default, and this can save you a ton of time, potentially a ton of money, and just make your life much simpler. Ever since I figured out how to do this, it's helped a lot. Part of my inspiration for this video was the EiV library. This library used the same version of accessing the Unreal Engine third-party libraries, and it allowed the creation of a large amount of free blueprint functions in this plugin that can perform all of these actions. Now, this was just EiV, and so I thought it would be nice if everyone was able to actually know how they can do this themselves. Some of these other plugins out there that help with some of the stuff related to these, you might even have to pay for them. Now, if you just need a thing or two, you can go right ahead and just program what you you need yourself. So if you followed along, you now have a working example you can go ahead and build off of. And if you did not follow along, I'm going to be going through and commenting my code and posting it in the video repository where you can go ahead. It's right on GitHub, and just download the project that I created here. Hope this video helped you on your development journey in Unreal Engine. If you found this video helpful or informative, don't forget to leave a like so you can help us know what's helpful for you and help other people find it in the vast YouTube algorithm. And if you're looking for more information like this, don't forget to subscribe to Galactic Games. You can get updates on what we're working on. Also, don't forget to go check out the Galaxy. That is our Discord community where you can interact with others using our products that we work on and develop, such as EiV. So I know it's just a quick little video, but hope it helped and that your development is now going to be much easier.